Exercise 2.6, this is on page 97. This exercise involves determining whether a sentence is a well-formed formula, right? That's what WFF stand for, well-formed formula. What that means basically is it grammatical in the language of sentential logic, right? So if you saw a sentence that said something like, dogs are furry, right? That's a grammatical sentence. If you saw a sentence that said something like are furry dogs, that would be confusing, right? Same pieces, but they're not put together in the right way to make a grammatical sentence, right? So just like English, there are rules of construction for sentences in sentential logic. And if you break the rules, you end up with a non-grammatical or a non-well-formed formula. All right, so again, I'm going to do some of the even ones because the odd ones are assigned, or some of the odd ones are assigned. And you need to read the directions for this carefully because he says, which of the following expressions in SL, that's sentential logic, are strictly speaking well-formed formulas? Which of them do we normally consider to be well-formed formulas, given the just mentioned liberties we take with the grammar of SL? So when he says just mentioned liberties, that's referring to the section that precedes this, section 2.6. So you need to read that carefully because he talks about what liberties are allowed and what liberties are not allowed. All right. So I put SS here for strictly speaking, right? Is this strictly speaking well-formed formula? Sometimes the answer will be no, and yet it'll normally be a well-formed formula. And again, it's sort of like English. You know, there are liberties you can take. You can say sentences that aren't strictly speaking grammatical, but everyone understands them, and so we accept them, right? Like if I say, who's the professor for this class, and you say Professor Bizdak, right? Your answer, Professor Bizdak, is really shorthand for Professor Bizdak is the professor for this class, right? But you don't have to say that whole sentence. It's an acceptable shorthand, and the person who's talking to you is going to infer the rest of that, right? So it's similar to that. Okay, so number 2, we have not F, right? We have parentheses around the whole thing. And again, you need to look at the rules for forming grammatical sentences. They're on page 94 of the text. And the first rule is every atomic sentence as represented by an individual uppercase letter is a well-formed formula. So sentences have to be uppercase letters, right? Rule number 2, if P is a well-formed formula, then not P is a well-formed formula, right? And P here means like any letter, right? So here we could start with F. F is a well-formed formula because of rule number 1 that says any, atomic sentence is a well-formed formula. Rule 2 says that for any well-formed formula, we can put a negation in front of it, and that'll give us a well-formed formula. And what rule 2 says is any sentence that's a well-formed formula, we can put a negation in front of it. So now, since not F is a well-formed formula, we can put a negation in front of it. And that's going to be a well-formed formula, right? And we can put a negation in front of that sentence. And that's going to be a well-formed formula, right? So any sentence that's a well-formed formula, you can put a negation to the left of it, and that too will give you a well-formed formula. So you can have as many negations to the left of a sentence that you want. So strictly speaking, yes, that is a well-formed formula. And notice it has parentheses around it. Technically, I don't think you even need the parentheses, but they're not wrong. And so strictly speaking, yes, and normally speaking, yes. Okay, second one, all right. We have H conditional T1, conditional T1. Now, subscripts are allowed. So again, if you look on page, where is that where it talks? I forget specifically, but in this section he talks about how you are allowed to use subscripts because there's only 26 letters of the alphabet, and so sometimes you might need additional letters, and for those you can use subscripts. Now there's no problem here with having the same sentence on both sides of the conditional. That's grammatical. It might not make much sense, or it might be obvious, but it's still grammatical. Now the problem with this, though, is it is not a well-formed formula, strictly speaking, because these square brackets are not part of sentential logic, technically speaking. But normally speaking, they're fine. And if you watched any of the videos where I do translations, you'll see I do use square brackets sometimes. So mostly you use them if there's a lot of parentheses, like more like down here. So again, strictly speaking, no, but normally they're fine. Number 6, A or A. Again, some people think this isn't well formed because you have the same letter on both sides. But again, as long as both parts of the disjunction are well-formed formulas, and we've already seen, according to rule number 1, any atomic sentence is a well-formed formula, then I can put it into a disjunction or conjunction or condition or whatever with any other well-formed formula, even if it's itself. So this one is good, strictly speaking. It has parentheses. It has disjunction with a sentence on each side. So strictly speaking, yes, and normally speaking, yes. Number 8, M conditional, M and N biconditional R. Right? So again, we already know, strictly speaking, this is no good because of the square brackets. But is it normally speaking good? Well, the other thing we have to check is to make sure the parentheses match up. Right? You have to have the same number of right parentheses and left parentheses. Right? So we have one left bracket here, one right bracket here. We have 1, 2 left parentheses and 1, 2 right parentheses. So that's fine. So normally speaking, that's okay. Even though, strictly speaking, you're not allowed to use square brackets. Also, strictly speaking, you should have parentheses around the whole sentence as well. Like that. Okay, but again, normally speaking, you don't need those. It's perfectly readable without them. Okay, number 10. If J, then P. This is bad, strictly speaking, because it's using English words instead of logical symbols. Okay, and for that same reason, it's bad, normally speaking. Right? You can't use English words in place of operators or in place of sentences. So this is no good. Number 12, this says A equals B, right? It's not a biconditional. It is just the equal sign. It's kind of hard to see when it's so small. Let me see if I can make it bigger. Maybe not. Oh, there we go. Okay. So A equals B. Just checking my text to make sure it is an equal sign, not a biconditional. Is no good, strictly speaking, because the equal sign is not part of the language of sentential logic, and so normally speaking, either. Now, later, or this other system of logic that we'll talk about later in the semester called quantifier logic or predicate logic, does use the equal sign for identity. It means A is identical to B, right? But in sentential logic, the equal sign is not part of the symbolism. So that's a no, strictly speaking, and no normal. All right, 14. Okay, so the main thing we have to check here again is the number of parentheses that they match. We got 1, 2, 3, 4 left parentheses, 1, 2, 3, 4, 5 right parentheses. And again, I'm just looking at my book. Oh wait, I did miss one in the book, didn't I? So the book does have one here. Okay, so we have 1, 2, 3, 4, 5 left parentheses, 1, 2, 3, 4, 5 right parentheses, and so that's good, strictly speaking, and it's good normally speaking as well. All right, all parentheses, they match up, and the whole sentence is in parentheses. All right, 16, we've got O, conditional O, conditional O. Again, there's no problem with repeating the same letter. That's fine, but there is a problem here because there are no parentheses, all right? So strictly speaking, it's no, and normally speaking, it's no as well. So parentheses, anytime you have more than one atomic sentence with an operator that's not the negation, you need parentheses, all right? So again, if it's simple, if it's just like A and B, normally speaking, you don't need parentheses around that because the parentheses add nothing. There's no possibility of confusion. But now imagine you have a sentence like this, right? Now this is bad. Normally, this would be not strictly speaking okay because strictly speaking, you should have parentheses around it. But normally this would be okay because leaving the parentheses off doesn't change the meaning at all. Here, though, both strictly speaking and normally speaking, you need parentheses because otherwise it's ambiguous, right? This sentence could mean this, or it could mean this. And those are going to have different truth conditions, right? Those are not the same sentence. So if you just write it like this, it's incorrect because it's ambiguous whether you mean this or whether you mean this. So you have to have parentheses once you have more than two atomic sentences. Right? And again, or it could be like this. So if you just have two and they're connected with one of the operators, then you're fine, right? But if you have more than two atomic sentences connected, then parentheses are necessary, all right? So keep that in mind, and also always make sure you have the same number of left and right parentheses around a sentence. Some of you maybe are starting to think about this in terms of math, and there are similarities, right? Like think about operations, right? If I have 2 times 2, right, that's fine. If I have 2 times 2 minus 3, right, that's ambiguous, right? It could mean 2 times 2 minus 3, or it could mean 2 times 2 minus 3, right? And again, these are going to be different answers. This one is 1. This one, oops. This one is 2 times negative 1, right? So negative 2. Now, it's true that in math, the order of operations is usually defined. So even if you saw a sentence like this, right, we all learned those mnemonics when we were kids about my dear Aunt Sally or whatever, multiplication, division, addition, subtraction, like do it in that order, right? But it still has to be specified. Now, there's no nice mnemonics for logic like that, so you always have to make sure you have parentheses in order to avoid having a sentence that's ambiguous. Ambiguous meaning it could have more than one meaning. Okay, so again, just to review a couple key points. Square brackets, strictly speaking, not allowed, but normally they're fine. You can have as many negations to the left of a sentence as you want. There's no problem with that. You can use the same letter multiple times within a sentence. There's no problem with that, right? Again, as long as it's a well-formed formula, you can put 2 well-formed formulas into a disjunction even if they're the same sentence. So that's not a problem. No English words are allowed, all right? No equal sign is allowed in sentential logic, and you need to have parentheses whenever you have, multiple sentences and multiple connectives. All right, hope that helps.